Welcome to Magic Academy. We are still on organic chemistry, where we are using IUPAC nomenclature for organic compound. Watch the example on the board. Let every of these laws we have learned, let it come to play now. If you watch from what you have on the board, you have a straight chain hydrocarbon. 1, 2, 3, 4, 5, 6, 7. 7. The carbon chain there is 7. And any carbon chain, any organic compound that has 7 carbon chain, the prefix is still hex for 7 carbon atom. So if you watch clearly now, it has a functional group there. There is another example I will show you maybe in our subsequent videos where OH is acting as a substituent group and not as functional group. But here it is acting as a functional group, which means the name of this thing will end with OL. Don't forget, this one is functioning as a functional group, it is acting as a functional group. So you will always start from the side that you will start numbering, which will give you the closest number to this functional group. If we start here to number 1, 2, 3, 4, 5, carbon number 5 has the OH, but if you start here 1, 2, 3, carbon number 3 has the OH. So if I may ask you, where exactly can we start to number? It is from the back. 1, 2, 3, 4, 5, 6, and 7. Don't forget that apart from the OH functional group, you have other substituent groups. Remember, we have done alkyl group. We have other substituent group like the CH3 here, and that CH3 is here. They are all substituent group. If you can number correctly a carbon chain, the naming is looking at you because I have finished numbering them now. So the name is just glaring here now. So if you want, the name will start with what? The substituent group as we have learned previously. So the name now is 4, 5 dimethyl heptane 3-ol. Check it. Don't forget that immediately you finish numbering the carbon chain, if there is any substituent group there, just as I have CH3 here, which is a methyl group, you first of all name substituent group before you now come to appreciate the number of carbon chain it has as well as the functional group. This thing simply means that carbon number 4 has a methyl group. And if you check closely at carbon number 4, you see CH3, it's a methyl group. If you go to carbon number 5, it has another methyl group. And now our chain hydrocarbon is still heptane. At carbon number 3, you see OH group. So the name is simply 4,5-dimethyl heptane 3-ol. Remember that this name can still go 4,5-dimethyl 3-heptanol. I always write it in 2 ways so that any one you see, you can correct it. 4,5-dimethyl 3-heptanol or 4,5-dimethyl heptane 3-ol. Let's check example 2. The other example there is now on the board. If you watch carefully, if you know organic chemistry very well, you will not be tempted to add any hydrogen here because the bond surrounding this carbon atom is complete. 1, 2, 3, 4. Each carbon atom will be surrounded by nothing more than 4 covalent bonds. So if you watch here, we have a functional group as well as a substituent group. The functional group here is simply triple covalent bond. And the substituent group there is chlorine group and another chlorine group. So if you watch, you will start to number from that side that will give you the lowest number to the functional group. The functional group we have here is what? Triple covalent bond. Which means the name of this compound will end with YNE. Because that is the group of organic compound that has triple covalent bond. Alkyl. We have done all these things. So you can go back and watch the video on alkyne. So if you watch now, without wasting much of our time, preference is given to functional group before any other substituent group. Don't forget, we have done the rules for all these things. So I am starting here to number 1, 2, 3, 4, 5, and what? 6. I have numbered my carbon chain. Because if you doubt me, if you start here to number, it will be 1, 2, 3, 4. 4 carbon atom, number 4 carbon atom is the one carrying the triple bond. But if you start here, carbon number 2 is carrying the functional group. So the closest number will always have its way before any other one. So after numbering this and now, the name is looking at me right now. First, we have 6 carbon atom. The prefix for 6 carbon atom is hex, Hex. But carbon number 4 has two chlorine atoms. So what we are going to do now is simply naming the substituent group, which is what? 4 dichloro has just check the name. 4 dichloro has 2 yarn. Why? Has 6 carbon atom. 4. Carbon number 4 has chlorine group. Another carbon number 4 has another chlorine group. To appreciate the 2 chlorine groups, I put di. Di means 2, which means we have 2 chlorine atoms or 2 chlorine molecules in the same carbon number 4. Now, carbon number 2 is what carries the functional group. That is why the name ends with what? YNA. So check it very well so that we go to the next example. Let's check the example number 6. We have 1, 2, 3, 4. 4 carbon atoms. So we start here to number 1, 2, 1, 2, 3. So here is the closest. 1, 2, 3, and what? 4. So the name simply means 2,2-dimethyl butane. So in this case, there is no functional group. It is just normal alkane. If I start here to number, it would have been 1, 2, 3. Carbon number 3 will be the one carrying these methyl groups. But if I start here, carbon number 2 will carry the methyl groups. So the closest number is 2. That was why I started from the front to number. Okay, 2,2-dimethyl butane. Let's check example 7 on the board. If you watch, we have a functional group here, which is what? Arachidonic acid. COOH. That is the functional group present in arachidonic acid. And in this one, there's no doubt. We are starting numbering from the functional group. 1, 2, 3, 4, and 5. So which in the same carbon number 4 has different substituent groups. We have chlorine group and we have bromine group. Now the question now is, which one do we name first? That's when the rules of alphabet will come into play. B and C, which one comes first? I believe B comes before C. So I'm going to name bromine first before I name chlorine. That if you watch that my rules I listed in the previous video, I say when you have more than 2 different substituent groups in the carbon chain, rule of alphabet come to play. So here now I'm naming bromine first. 4 bromo, 4 fluoro, pentanoic acid. Check it again. 4 bromo, 4 chloro, pentanoic acid. Pent because the carbon chain is 5. Carbon number 4 has bromine group. Carbon number 4 has chlorine group. So just to name it 4 bromo, 4 chloro, pentanoic acid. That is a very good example of rules of alphabet. Watch out for other examples. Example 8. Just watch the structure. 1, 2, 3, 4, 5, 6, 7, 8. If I'm counting straight, I will get 8. 1, 2, 3, 4, 5, 6, 7. 7. 1, 2, 3, 4, 5, 6. So the longest one is what? Straight. 8. So anyone that doesn't fall along this line is now considered as a branch, which means you have three branches here. You have this one, you have this one, and we have this one. Please remember what we call branch. It's not when you have hydrogen here, you say it's a branch. What we call branch is any other carbon that is not along this chain is considered as a branch. Not when you see hydrogen here, you say this is a branch. I mean carbon. If you want, this is carbon to carbon, is a branch. This is carbon to carbon, is a branch. This is carbon to carbon, is a branch. But carbon to hydrogen is not a branch. I hope you are getting it clearly. Okay, now how do we name it? We have two different substituent groups. This one is methyl group. This is ethyl. 2CH5. Just this in that means C2H5. 1, 2, H. 1, 2, 3, 4, 5. So the rules of alphabet will play a major role here. E and M, which one comes first? Remember, ethyl. Ethyl is E. Methyl is M. So E and the M, which one comes first? It is E, which means we are going to consider E first before M, which is methyl. 1, 2, 3, 4, 5. Carbon number 5 carries a tail, but 1, 2, 3, 4. Which one is the closest? 4, I guess. I am starting my numbering from behind. So 1, 2, 3, 4, 5, 6, and 7, 8. Remember, I'm supposed to start from here. But if I start here, it is carbon number 1, 2, 3, 4, 5. Carbon number 5 will carry the tail. But if I start here, carbon number 4 carries the tail. The lowest number will always have preference. So the name is here now. The name is 4-ethyl. Remember why we started with ethyl? Rules of alphabet. 4-ethyl, 2,7-dimethyl, octane. That is why I say if you can number this thing correctly, the name will be looking at you. Look at it, 4-ethyl. Carbon number 4 is carrying ethyl group. It doesn't mean that ethyl group is 4 in number. No. It means that carbon number 4 is carrying ethyl group. Now, carbon number 2 has methyl. It is here. Carbon number 2. Another carbon number 7 has another methyl group. So 2, 7. To appreciate the two methyl groups, I put that. How come octane? The carbon chain has 8 numbers of carbon. That is octane. Okay, let's check this example. If you know chemistry very well, no need of adding hydrogen here and here because total number of bonds are complete already. So here now we have a functional group, which is what? Alkene, double bond. That is to say that this whole head will merely act as a branch. So if I start to number all these things now, look at how it is going to be. So if we are starting here to number, it will be 1, 2, 3, 4, and what? 5. Carbon number 2 is the one carries the functional group. So the name simply means 4-hydroxyl, 4-hydroxyl, pent, 2-N. Don't forget the group it belongs is INE because of presence of a double bond. Now, lastly, this one, anyone you decide you want to number, it is still the same thing. And lastly, we have 3 carbon chain there, which is pro. So the name of this is simply propan 1, 2, 3 triol. As you can see, OH is alkanol. So that is why the name is ending with this. Carbon number 1 carries OH, carbon number 2 carries OH, carbon number 3 carries OH. To appreciate the 3 OHs in quotes, I put triol. So that is it. We will keep on naming all these things from the structure until we get to a point where we will start to put the name, then we draw it. Happy watch.